Good morning everyone. Today we are going to learn basics of an Opamp. So Opamp stands for operational amplifier. This is the symbol of operational amplifier, which is a three-terminal device, namely inverting terminal denoted with V1 and non-inverting terminal denoted by V2. So here VID is differential voltage between these two terminals. We can calculate actually the difference between two terminals in the form of voltage, and we should take output by third terminal denoted by V0. We know V0 is directly proportional to VID, but we know that V0 is equal to AD VID. Here AD stands for differential voltage gain of an IC 741 op amp. So finally from this we should get AD is equal to V0 by VID. Simply we can call, or we can define this differential voltage gain of an op amp is defined as the ratio of output voltage to the differential voltage. This is we can calculate as VID is equal to V1 minus V2 or V2 minus V1, but it has heavy voltage gain inbuilt is about 10 power 6 to 10 power 8 decibels. Let us discuss the characteristics of an ideal op amp. Also, see, every ideal op amp has formal these ideal characteristics. Each, that is infinite open loop gain denoted by G, V0 by Vt. It has infinite open loop gain and as infinite input impedance. Here impedance is also referred as a resistance of an op amp. Due to that, it has zero input current and also has zero offset voltage. Without getting input current, we doesn't get offset voltage also, and it has a bandwidth which is equal to zero with a phase shift and infinite slew rate. So later we discuss about this. And as output impedance also are not zero is denoted with R out. Why we are getting this output is zero means from these, due to high input impedance we doesn't get output voltage that is denoted with zero and as zero noise. And further we need to discuss one more important point, that is infinite CMRR. CMRR is commonly referred as common mode rejection ratio. So ideal op amp has low CMRR and as infinite power supply rejection ratio. So here, as we know, CMRR is that output voltage is directly proportional to VID and also directly proportional to VC. Here VID is referred as a differential voltage gain or open loop gain, and and AC are represented as common mode gain. So CMRR is denoted by rho, which is also defined as AD by AC, meaning is that rho is CMRR is defined as a ratio between differential voltage gain or open loop gain to the common mode gain. In ideal op amp, we should represent this as rho dB is equal to 20 log base 10 AD by AC, and the slew rate it as SR is equal to dV0 by dt by maximum volt per second. So whenever we are dealing with an op amp ideal, that is ideal op amp, which has already we discussed two mode gains, which are common mode gain and open loop gain. As we know, whenever we are applying same signals between these two input terminals, that is V1 and V2, which can neglect the common signals. That is the main advantage of any differential amplifier. But here we are calling this as a differential amplifier, but initially here we are subtracting the two input voltages, that is inverting and non-inverting terminals. So finally, for ideal op amp, rho has infinite, that is CMRR has infinite, and it has high CMRR. For practically we use a 10 power 6 of a rho value, and CMRR is also called figure of merit, which is denoted with 20 log base AD by AC. This is simply about basics of an operational amplifier, and please subscribe the channel for more latest videos. Thank you very much.